Hi everyone, welcome to Spam Text Classification. We will start this tutorial with the introduction of the natural language processing, in which we will see what are the components of the natural language processing, what are the applications of natural language processing, and what are the tools available to use with natural language processing. Thereafter, we will move toward the spam text classification. We will see some techniques of the spam text classifications like the word embedding techniques, some of these techniques like the TF-IDF term frequency, inverse document frequency. Thereafter, we will start building our application, and we will be doing all these with code along tutorial. That means I'll be showing you a step-by-step process how you can write all these codes by yourself. Thereafter, we will see how you can do the data balancing, and then you will see how you can do the data exploratory analysis. Finally, you will do the model preparation and training, and after the training, you will test your model how it is working in real world, and then finally you will save your model. Once you have saved your model, then we will be using a Streamlit application like this, a Streamlit application where we will be building a front-end UI. So in this front-end UI, you will be using a title like predicting if message is spam or not, and then you will be entering a message here to predict the final outcome. Something like this. I predict this message is spam, but if I change it like, hey guys, how do you doing? Something like this. Now you should be able to get the message classification as a ham here. So these are the total the steps which we are going to cover in this video. Alright, so without wasting time, let's go ahead and get started with natural language processing introduction presentation. Hi everyone. Welcome to Natural Language Processing Introduction class. In this lecture series, we are going to discuss about the Natural Language Processing Introduction, and then we will talk about the applications of Natural Language Processing. Thereafter, we will move forward and we will see how you can build a Natural Language Processing application for a spam text classification. We will also see how you can build a Streamlit application for your model. Let's go ahead and try to understand that what is natural language processing. This natural language processing is quite old domain. It has been like 30-40 years since the natural language processing is there in the industry. But earlier, because of less the computation availability, it was not that much of the famous. But now we have very powerful computers and powerful GPU. Along with that, the powerful models have also started coming. So we have started building a powerful machine learning models. Traditionally, the computers were only able to understand and they were only able to process the numerical data. But nowadays, NLP models are able to process these text data due to the conversion of these text data into a numerical format. And the process of converting these text data into numerical format is known as the embeddings and encodings. And these NLP is a branch of computer science where we study about the text data and human language. Here are some of the use cases for natural language processing. Some of the use cases of natural language processing like the health record, customer satisfaction report, Google engines or Bing engines or any kind of the search engine uses NLP applications. Other devices like the Amazon's Alexa, Apple's Siri or Google's Home, all these are also using NLP applications. In industry, the HR also uses the CV parsing and resume parsing techniques to find out the best match for the candidate as per the job description. So these techniques are used as the NLP applications. Some other basic techniques and the concept in NLP applications are like NER, tokenization, stemming and lemmatizations, bag of words, natural language generation, sentiment analysis, sentence segmentation, chatbot. So basically you can see that these are the very wide fields. So some of these techniques, and these are the applications of the NLP. So these are the process how the NLP is done here. You have text input, thereafter segmentation and the tokenization of input data is done there. Thereafter the cleaning of text data is done, then vectorization and feature engineering is done. Thereafter a machine learning algorithm can be applied once text data is converted as numerical data, and then finally interpretation and results are calculated here. So here are some of the tools for the natural language processing like Keras, Spassy, NLTK, Hugging Face, PyTorch, TensorFlow. All these are tools to use the natural language processing. Some of the algorithm tools we have like PyTorch, TensorFlow, Scikit-learn, Keras, Hugging Face, Python. So all these are the algorithms or programming language or framework which we use to design our NLP applications. As I discussed earlier that we need to convert text data into numerical data. So this word embedding technique is a technique to convert text data into numerical data. So here we convert text data as numerical data. There are many ways to convert these text data as numerical data, like traditional word embedding techniques like word bag of words, count vector, TF-IDF, co-occurrence matrix. A static word embedding techniques without any context, or you can say non-contextualized word embedding is word to vector, glove vectors, and fast test. These are word embedding techniques. Then you have the context-based word embedding techniques like we have Elmo, GPT, GPT-2, and BERT. So these are the context-based word embeddings. So how would you understand that, how embedding works? That you can understand by this example. Suppose that you are given with the 4 set of tokens: cat, kitten, dog, and houses. So what are the similarity? Based on similarity, these will be projected into a vector space. So similar kind of tokens will be placed together into a vector space. Like cat and kitten, these are a similar kind of tokens. So these are placed together into a vector space. Thereafter you see the dog and houses. So which one is more similar to cat and kitten than dog and houses? It's the dog. House is not similar than the dog. So the cat, kitten, and dog have a less distance as compared to cat, kitten, and houses. You can similarly see in second example where we have man, women, king, and queen. So the man and women are more similar than the man and the king, so these are placed together. And in meantime, man and king is more similar than the women and king, so these are placed together, and the women and queen is also placed together. Well, so here are some more applications, some modern NLP applications like the language translation, smart assistants like we use the Google's Home Pod and Apple Siri, and then Amazon's Alexa. You have a document analysis, online searches, predictive text data, automatic summarization, social media monitoring, chatbot, sentiment analysis, and so much more. Here you see the list of the models which was published by these famous companies. So these models were actually published by the Google, some of other models were published by the Facebook, and some models were published by the OpenAI. So some of these are the major player in NLP models. So currently they are making large language models. These are the very powerful models. BERT models were developed by the Google. So you can say that the NLP revolutionization started since 2017, whereas machine learning revolutionization was started around 2012 and 2013 once ImageNet model was introduced. Thereafter, the transformers was introduced for the NLP applications, and thereafter a bombardment of these models have started. So some of these large language model are the examples here. If you want to write something, a content writing, you can use any of these applications. If you want to try out AI generative coding, so you can use any of these applications. If you want to use any AI development tools, you can use any these AI development tools, or you can use the chat. So these chat and the communications, AI chat and applications, you can use these, and then the business operations, you can use these. Some infrastructure layers are here, like you have OpenAI and Hugging Face, which powers the fine tuning and the inferences. The hardwares are leading by the leader of the hardware is NVIDIA here, and NVIDIA has been also creating NLP models. And the other major companies for the NLP models are there: the Facebook, Google, and OpenAI, and some of these other companies which are making advanced NLP models. Alright, this is all about the introduction. Let's go ahead and get started with coding. Alright, let's go ahead and get started with building spam text classification. So before building our spam text classification, we need to understand some of the NLP application techniques. So some of the NLP techniques are like the n-gram techniques. So these n-gram techniques are used to group the multiple tokens together. So in n-gram technique, there is unigram. So in unigram, you have please turn your page. So these are tokenized as individual or a single word. Thereafter, you have here a bigram. So in a bigram, you will get here the group of tokens, the group of two tokens together. You have please turn your and your page. And in the trigram, you have here a group of three tokens together. Please turn your and turn your page. So what's the benefit of doing this? Suppose that if you break down the individual words at the individual tokens, and those are placed at some distance, like in the bag of words here, then the context of the words which are together are lost here. But if you put it as a bigram, then the context will be exactly, context will be kept together. Suppose that if you have a word which is consist of, let's say, two words, then these bigram will help there, like New Jersey or New York. Then you will see there is the two word or the two tokens, and if you use the bigram in that case, then it will keep the context together. Well, other techniques for the natural language processing is bag of words. So how this bag of word works, that you can understand with this example here. In this example, we have a two sentence. Which book is this? And this is book, and this is math. So in the first sentence, you see there 1, 2, 3 and 4 words are there. In the second sentence, there are 7 words or 7 tokens. So together if we combine, there are 11 tokens. But if we see here the unique tokens, we get here just 6 tokens or 6 words. So in the first sentence, we see there the count of and is 0 because there is no and found in first sentence. Similarly, we see book is this and which these are found in the first sentence, so the count is 1 and this count is 0. In the second sentence, we see there is and this, these are counted as 2 because the count of these are 2 here, so the 2 is here and 2 is here. So this is the bag of words, that's how it works. Like we have previously discussed, machine learning algorithm needs numerical data. So this text data now got converted as numerical data. Now this numerical data is ready to be used with machine learning algorithms. But these numerical data are not accurate, so the bag of words we cannot use directly with machine learning classification. So what we can use term frequency and inverse document frequency together. So those are somehow more accurate, a little more accurate than the bag of words. Well, so this term frequency is simply the ratio of count of words present in the sentence divided by length of the sentence. That means if I count the frequency of and, it says that 0, or you can see there if you combine it with the bag of words. So in the first sentence it was not available, so the 0 divided by 4, that's the 0. Then 1 divided by 4, that's the 0.25. Thereafter you have 1 divided by 4. So why I am saying 4? Because there are 4 tokens in first sentence. So the 4, it would be divided by 4, the first row. And there are 1, 2, 3, 4, 5, 6 and 7. So there is a 7 token in second sentence. So these will be divided by 7. So the first one you divide by 7, you will get here 0.1428, and if you divide it by 7 you will get 0.2857, which is just a double of this one. Alright, let's go ahead and move to the inverse document frequency, that is the IDF. So this inverse document frequency, what is this? So this is something like you have a log of 1 plus n divided by n plus 1 and then finally plus 1. So this capital N means the total number of rows. So currently we have total number of rows present as 2, and then this becomes 1 plus 2, that is the 3, and this N is the total number of rows in which word is present. So if we compare for the first one, which is AND, so the AND, for the AND inverse document frequency will be 1 plus 2, which is total number of documents. So this will be always 3 here. So 3 divided by, and in how many AND is present? It is not present in first one, it is present in second one. So the 1 plus 1, it is 2. So 3 divided by 2, which is 1.5. And if you take the log base E of 1.5, you will get the result of 0.40, and there is a plus 1, so it becomes 1.40. Similarly, it calculates for the second one, the third one, fourth one, fifth and sixth one. Do remember, it does not calculate here row wise, but in fact it calculates here as a whole inverse document frequency. Now this whole document inverse frequency gets multiplied by these term frequencies row by row, and then finally you get the final term frequency inverse document frequency, which is TF-IDF. So the term frequency gets multiplied by the gets multiplied by IDF, so it becomes here TF-IDF. So the TF-IDF of these first two sentences will be this one. So with this we can see that which word is the most important word here, or which word is the most important token. So while processing our data, while moving ahead, so there are the the steps which we are going to follow here. So the steps will be like here: loading the data. After loading the data, we will do the data visualization. After data visualization, we will do the train test split, and after the train test split, we will do here the model building, and thereafter training, and then we will do here evaluation, and then finally we will do here Streamlit application building. So for data visualization, here I have a very detailed course, data visualization course, which you can click and you can open it here. Data visualization in Python masterclass. This one is having like 22 hours of total lecture, which you can see and you can master yourself in data visualization. Alright, let's go ahead and get started with the coding part. We will be using here some of the basic libraries like pandas, numpy, matplotlib. Thereafter, we will load our data and then we will do the visualization. So I write here import numpy as np and then import pandas as pd, and thereafter we do here matplotlib.pyplot as plt. So we have imported necessary libraries here. Let's go ahead and now load the data. So where is the data? So first of all, we need to go here github.com/Lakshmi Merit. Then in this Lakshmi Merit, you need to come to the repositories. You need to search here CSV. In this, you will get all CSV ML data files download. And you need to scroll it down a little. You will see here spam.tsv data. So this is the data which we are going to utilize. In this data, you have here labels and messages. So these labels we will be using for our supervised learning. You need to click on raw. So it will open here as raw format, and then you just simply copy this whole thing from there, and then you need to commit here and then paste it as pd.read csv, and then since this is the tsv file or the tab separated file, you write here the separator is equal to / as t, and then you write here df.head. So it becomes the data frame dot head. Here by mistake I put 0. I shouldn't be putting 0. So df.head says that these are the data. The first 5 rows of our data is displayed here. Alright. So now we have got our data. Let's go ahead and quickly do some basic analysis of our data. Like you can do df.isNull just to check that if there is any null value with our data, so that you can check df.isNull.sum. Here you have label, message, length and punctuation. So none of columns have null values. That's mean all values are filled here. You can also check the shape of your data frame, where you will see 5572 rows are there and there are 4 columns. And then you put here the df label value counts. So df label dot value counts, here you will see there are total 4825 ham messages, which is legitimate messages, and 747 spam messages are also there. One more thing you should notice here, that your data set is not balanced. It's imbalanced data. So you need to first balance your data. To balance your data, we have to undersample these ham messages. So to do these undersampling our ham messages, I'm just gonna write here data set balancing. Let's go ahead and do the data set balancing. So I have to first filter out the ham messages. I write here data frame df, and then I need to filter out label equal to ham. So in this way, what I do here, I filter all the data rows which have label equal to ham. Now if you check the shape of ham, you will get exactly the same what you had seen here. Similarly, we are going to get it for spam as well. So I put here a df, and then I put here a label, and then I'm gonna put it here as a spam, and then I put it here as spam, and then I put it here as a shape. So what do I see here? I have a spam equal to the data frame label equal to spam, and then here I see spam.shape. In this I have here total 747 rows. So we need to get these 747 rows from the ham messages so that we can balance our data. So for that we have to use here the sample technique. So I write here ham equal to ham dot sample, and thereafter I need to write here the shape of spam messages. So I write here shape of spam messages. I'm taking 747. Thereafter, if you check the shape of ham messages, you will see total 747 rows are there. So now we have balanced our data. It is time to concatenate our ham and spam messages together. So I write here the data is equal to the pd.concat, and then I need to make here a list of ham and spam messages. I'm gonna combine it on axis equal to 0. So axis 0 means I'm going to combine these data together on row wise instead the column wise. Thereafter I write here ignore underscore index equal to true. That means the index will be ignored while joining these two tables. Now if you check the shape of the data, you will see total 1494 rows, where each of these classes have 747 rows there. Thereafter I'm gonna check here the head of the data, or you can simply check it the sample of the data, where I provide 5 sample of the data, so it will randomly get the 5 samples from the data. Now we are ready to build our model, but before that one more thing left out, that is the exploratory data analysis. Let's go ahead and do the exploratory data analysis. So before doing the exploratory data analysis, let me tell you again here at my Udemy course, data visualization in Python master class. So the link of this course is given here. You can just click on this link. You will be redirected to this course, and you can see here it is having so many applications for the data visualization. So some of these techniques I'm going to use here for the data visualization. So the first of all, I need to set here matplotlib parameters for better data visualization. So I write here plt.rc params. In this I write here figure.dpi, which is dot per inches. So I'm going to set here the 200, so it will make sure that our image having high quality. Thereafter I write here the pc.rc params once again, and then I write here figure.figsize, and then the size of image will be here 10x4. Thereafter I write here the plt.style.use, and then I use here ggplot. Let's go ahead and run this. Now as soon as I run this, what do I see here? I see here the plt.rc param and plt.style is successfully set for our matplotlib library. Now let's go ahead and visualize our ham and spam messages. So but before that, we can see the columns of the ham and spam messages. So how many columns are there? There are 4 columns. We have label, message, length, and the punctuation. So we want to understand that how many characters are there for ham messages and how many punctuations are for ham messages. Similarly, we will check for the spam messages as well. So I write here the plt.hist, and thereafter I write here the ham. So in the ham messages, I'm gonna get for the length, and then I write here the bins equal to 100, and thereafter I write here alpha equal to 0.7, and then I write here the label is equal to ham. So what is this? So I'm going to visualize the length of the messages for the ham. Total number of bins are 100. That means there would be 100 bin, and the transparency level of those will be here 30%. Thereafter I set here the plt dot legend, and then the plt dot show Let's go ahead and run this. So as soon as you run this, you will see here a very beautiful plot here. So in this you have ham messages which have the total, mostly the length of the messages are less than 50-60, but there is also some skewness here which you can see like in between 100 to 200 as well. Similarly, we can check for spam messages as well. So you need to write here the spam, length bin, everything as it is, and here I write spam. So one difference we see for in between the ham and spam messages, that ham messages have a smaller total number of the characters in the messages, but the spam have large number of the character on average in the messages. So why this happens? Because anyway the spammers always try to use all the available space in their messages. So they write a very long messages like you have won some lottery ticket and you can get a coupon, you can redeem it, and so many stuffs they write here. Alright, let's go ahead and copy this whole thing from here and check out with the punctuation as well. So here I write here the punct, which is the punctuation, and similarly I write it for the punctuation here. Well, so now in the punctuation I again see that for a spam the number of punctuations are higher than the punctuations available in spam messages. So what you can do here, you can also write here the title of these. So you can simply write the plt.title, and in this I write here message length for ham and spam. So you will see there the title is set there. Similarly you can set here the title as well. So the plt.title, number of punctuation in ham and spam messages. So you just simply run this here. So what you see the number of punctuation in spam messages are a lot higher than what we see in ham messages. Let's go ahead and prepare our data for the training. So I write here data preparation for training. So for data preparation in the training, what I do here, I need to import all the necessary libraries from the sklearn first of all. So I'm gonna import from sklearn.model selection import train test split, and then from sklearn.ensemble model. So why I'm going to use here spam ensemble module, because I want to use here random forest classifier. So I write here import random forest classifier. Thereafter I write from sklearn.metrics import classification report here. So I want classification report to understand that what is accuracy of my model. Thereafter I'm gonna import here a container which can combine our random forest classifier and embeddings together. So that comes from sklearn.pipeline import pipeline. Thereafter finally I'm going to import here TF-IDF vectorizer. So from sklearn.featureExtraction.text, so I want to import here TF-IDF vectorizer. Alright, so all the necessary Python packages and the libraries are imported here. As I told you here, the set of the the steps here which I discussed at the starting. So the data loading is done, data visualization is done. Now the task is train test split, then the model building, training and evaluation, and then finally Streamlit application building. Okay, let's go ahead and do it here. So I'm going to do here the train test is split x train and x test. Thereafter I have here y train, and then I have here y test. So these I'm going to do with the train test split, and in that I pass here the data message. So this data message is our input, which is actually, you can say that data message is our input feature, a text data which will get converted as numerical data after running TF-IDF. Thereafter you have here data. In this data it has label, that's the target output, and thereafter we have here the test size. So the test size I'm gonna put here the 0.2, that means 20% data will be used for the testing. And the random state I set it here as 0. These are the some settings, like the random state sets that if you set a particular random state, no matter how many times you run, it will split the same set of the data. So thereafter you have shuffle, which is true, and then we need here stratify equal to data label. So why stratify? Stratify is needed to make sure that 20% of target output is shuffled as train data and as a test data, and rest 80% as the train data. Let's go ahead and check the shape of X train and X test. So I write here the shape of X train and X test here. So we have successfully we have done here the train test split. Now we need to build our TF-IDF vectorizer and random forest as a random forest model. So these things we are going to make with pipeline. You can simply write here the CLF is equal to pipeline, and in this pipeline you can make TF-IDF. So this is the name of the TF-IDF vectorizer which I am going to use in my pipeline. So I use here TF-IDF vectorizer. So thereafter this vectorizer, so this whole thing should be treated as a single module. Thereafter I'm gonna put our random forest classifier, which is RFC, and then I put here the random forest classifier. And in this random forest classifier, here I have n estimator equal to 100 and the number of jobs equal to -1. So this number of estimators says that how many estimators will be used there for the random forest classifier. Number of estimators says that how many decision tree or estimators are there in your random forest classifier, and n job equal to -1 will set that during the training all core available in your computer will be used for the training. So this will make sure that you train your model with the super high speed. Thereafter I write here the CLF.fit, and then I write here the X train and then Y train. It's going to train our model in no matter. Alright, it's just a matter of just a second. So it has just trained our model. Let's go ahead and do the prediction with our model. So I do here CLF dot prediction, CLF dot predict, and in that I pass here X test data, which is the test data. Now we have got here the prediction or the predicted data. Let's go ahead and print out the classification report. So I print here the classification report, and in this I get here Y test and Y pred. So the first one is true value, which is the reference value, and Y pred is this predicted value. I'm just gonna run it here. I can see here I have got a 95% of accuracy with our model. So this is not a bad accuracy on given that we have a very small set of the data, and we have also used a very basic technique of the data embeddings. So we have used a basic technique like TF-IDF techniques only. So if you use large language models or you use the transformers, you should be able to get a large accuracy, better than this. Let's go ahead and do a sample test if our model is doing good or not. So I write here CLF dot predict, and then here I write a 2 sentence. You have won lottery ticket worth 100 USD. Please click here to claim. Thereafter, you have here, hi, how are you doing today? Alright. So let's go ahead and run it. Now what do you see here? So the first one is classified as a spam and the second one is classified as a ham message. So with the message, it is pretty much clear that the first one is a spam and this one is legitimate message. So seems like our model is doing perfectly good, and the classes you can get to know about available classes ham and spam. So 0th index is ham and first index is here spam. Let's go ahead and save this model so that we can later on use this model for our Streamlit application building. So I'm gonna import here pickle. So I write here the pickle, import pickle, and thereafter I write here the pickle.dump. So with the help of this dump, I'm going to write this model. So I write here the dump CLF. That means I'm going to store our model, and then I'm gonna provide the file path where I want to store it. So I write here the model.pkl, and then I want to open our file as write binary mode. So you see there is no model as of now, but if I run it, now you can see it here. Let me just refresh it here. You can see model.pkl, just seconds ago it was modified. So a model.pkl is stored here. Let's go ahead and load this model and see there if you load this model whether it will work or not. You can simply load this model into a model variable where I write model equal to the pickle.load, and then you open, you provide a path where your model is stored. Obviously it's the same path where I used here, and thereafter you need to say that read this model in binary mode. You just simply do this, and thereafter I'm just gonna use this same thing here, but instead of the CLF I'll be using model because our newly model is loaded into model variable. So I use here model.predict. Let's go ahead and run this, and we see here the first message is predicted as a spam message and the second message is predicted as the ham message. So obviously this one is legitimate message and this one is a spam message. So we have successfully built here a spam text classifier. Now we are going to build a Streamlit application. We will be using here a Streamlit to build our NLP application. You can search that Streamlit here. As you search Streamlit, you will see it here. A Streamlit is a very fast way to build your data application. It's very much simple. You just need to import Streamlit as ST, and then you can use the Streamlit components to write your front end. So we need to go back here, and now I need to open this folder into Visual Code Studio, because you know our model is already stored here, and now we want to open it into VS Code Studio because now I want to write here the Python file. So the notebook writing was good if I use notebook, Jupyter Notebook, but for Python file I need to use here text editor. So I'm going to use the text editor here. That's the VS Code text editor. Now in this VS Code text editor, I'm going to create a new file here which is named as app.py. So this is the Python file in which we will be using that Streamlit application. So you can simply click on this doc. In this doc, it will say that you can click on getting started and then installation. Then it says that how you can install Streamlit here. So it's pretty much simple. You can simply do the pip install Streamlit. You need to come back to your VS Code here, and then you can come to you can come to here. Let me just see, where is that? You can come to the terminal and then you open here new terminal. Alright, so in this terminal you need to activate your Anaconda if you have not activated. So my Anaconda is already activated, otherwise you can write activate. You can write here the Conda activate base. So the base environment is activated in the Conda. Now you can install Streamlit. So I'm gonna upgrade Streamlit. Apart from this, you also need to upgrade your Plotly. So I did here pip install. Let me just zoom in a little so that you can see it clearly. Alright, so I write here the pip install upgrade Streamlit, and thereafter I write here the pip install upgrade Plotly. Alright, so we have here Streamlit and Plotly together. Now you also need to run it for Plotly as well. So I run it for Plotly. So these two things need to be updated here. So while these are getting updated, now we are ready to write our algorithms. So how these application is being there? We already have stored model.pkl. Now our task is to read this model and build Streamlit application, in which we will provide a message and there will be a button, and based on that it will predict whether a message is ham message or a spam message. So what I do here, you can run your app by typing here streamlit run app.py. So if I simply run this app here, you will see there it will start executing your app. Let me just see it. Let me just copy this from here, this URL, and paste that URL here. So this app is loaded here, but the difference is I am not able to see anything here. Okay, so not able to see anything, that is happening because I have not included anything as of now here. So I need to import here first Streamlit. So I write here Streamlit as st. Thereafter I need to import here pickles, because we want to import pickles. We have used this pickle to store our model. Now we need to use this pickle to load our model. So I write here loading the trained model. So I write here model is equal to pickle.load open model.pkl and then read binary mode. So with this the model will be loaded, and thereafter I'm going to create here the title. So I write here create title. I write here st.title, and in this I write here predicting if message is spam or not. So that's the title I'm using here. Now if you go back to your application, you just reload your application, you should be able to see the title. So now I'm able to see the title, but nothing more than the title. So we need to add here the more components, more Streamlit components. So to read our messages, we need to write here the text input component. So I write here message is equal to st.text input, and then here I write here the enter message. Now if you check, you should be able to see it here. You have got text input. So once you got the text input features or module there, now we are ready to add here button. So I write here if st.button predict. So basically what I'm going to do, I write here st.button. Alright. So I added here button, or you can add that button here itself. I write it like this. you can say that it is submit. Submit equal to the st.button, and if you check here, you should be able to see here the button. So it's not doing anything because we have not written final code yet. So I say here if submit. So if submit means when a button is clicked. So if button is clicked, then what will happen here? If button is clicked, then it is going to do here the prediction on the message data, and the model we have already loaded here. So for that I write here the prediction equal to model dot predict, and then I write here message. So whatever the message we entered there, now it will be passed here, and then the prediction will be made here. Let's go ahead and print out this prediction. So I print here this prediction. Along with that, I'm also going to write these prediction on the front end. So I write here st.write. Now if you check it here and you put some message, hey, how are you? And if I click on here predict, now it predicts that this is a ham message. That means this is a legitimate message, and it is a predicted here. So we can successfully see that how we do the prediction with our model by designing a front end. Now you can decorate this front end. So I'm gonna just decorate this front end. You can decorate it by removing these together, and then you can apply here one more if and else module. So I write here if prediction 0. Prediction 0 I am saying because it is a list, so I need this one. So if prediction equal to spam, then I write here st.warning, and in that I write this message is spam. Else I write here st.success, this message is legit, or I can say that this message is ham. After doing all these, then I write here st.balloons. So this one is making it fancy. Perfect. Let's go ahead and save it, and now we can reload our model here. Let's go ahead and do the prediction. So it says that hey, this message is legit, that's that this is ham message. But if we copy our previous example like here we had, then see what output it is going to give us. Now I copy and paste that here. I see this message is spam. Now congratulations, you have successfully built a ham and spam message classification using TF-IDF, and we have also successfully built here an application where you can predict if a message is spam or ham. The code of this file is shared on my GitHub. You can visit my GitHub link and download these code files. I would also suggest you visit my YouTube channel to watch more videos like this. Alright, this is all about in this lesson. See you again.